All right. Good morning, everybody. So today we're going to be talking about equations of a circle and graphing circles. So as you can see there with the warm up, that warm up has already been done. You should double check your answers. If this is a diameter, that automatically means angle y is a 90, which started to set us up for this problem here, where we made 3x equal to 90 and we solved for x. And then, of course, the fact that we know that this angle is a 90 up here, well, that also let us use the triangle 180 rule, where if I added the 34, the 90, right, where the y is located, notice how I didn't write 3x. We wrote it as 90 because that's what it is. And then, of course, there are 2y equals 180, and that's what led to me working out the problem and solving for the y as well. Now, when we're working on the equation of a circle and graphing circles, today it's all about really pulling information. And there's going to be two pieces of information that we're going to need for today. And so you'll see it shortly here. Now, here comes the definition again. It's a definition we've seen already. A circle, and of course, that's the symbol that we use for the circle, so we don't have to write the entire word, is a set of all points in a plane that are equidistant from a given point called the center. Now, that is going to be one of the things that we're going to need today. The center, in fact, since we have a little space, we're going to call the center HK. Because we always call everything X and Y. Well, we want to make sure that the center stands out a little bit more than usual. So we're going to call it H and K. It's still an X value and a Y value, of course. And then the next word that we're going to need, or the next thing we're going to need for today, is a radius. And we should already know what a radius is. It's a segment whose endpoints are, right? So the endpoints are the center. Again, it's going to be that HK and any point on the circle. And so just remember the radius. If we're thinking about a little circle right here, small one there. So we're thinking about a circle. We need that distance from the center to any other random point on the circle. Okay. And then, of course, it says a diameter. A diameter is a chord that passes through the center of a circle. But I think the most important piece is this. If they were to give us a diameter, remember, one diameter is equal to 2 radius. And so if that's the case, if they give us a diameter, remember, we're going to need a radius today. So if given diameter, divide by 2 to get radius. All right, so we're going to divide it by 2. That's the whole point of that little note there, that one diameter is equal to 2 radius. So again, today we're going to need two basic things. We're going to need to know the center of a circle, and we're going to need to know a radius. Those are the two things that we need in order to write the equation of a circle. So the question is, well, where does the equation of a circle come from? Well, here we have a picture of a circle on a coordinate plane. We did say, right, earlier, the center, we're going to be calling it HK, and then any other point. So here we see the any other point. But notice here's our center, but we need to give it its official name. The center is HK. Now, understand what that means, right? And of course, you know what? Let's bring this in. Here is our radius, or R for radius, that we're going to need. Let me move this up a little bit more here. Now, if they're coordinates, that means that there's some numbers that they're giving me on the XY plane. So for instance, the H, well, this right here would be our H value. If I go straight down, well, this would be our X value for that point. Whatever X is here, right? If this is the 0.53, then this would be the number 5. And so if you notice, all I'm trying to do is I'm trying to figure out how far it is from here to here. But they also have given me some Y values. And when we talk about Y values, well, I can go this way. But notice this was our HK, so that's our K value. And then if I go this way, just horizontally, we understand that that's the Y value that belongs to this point, which means if I connect that distance, notice what we have here. We've just created because I have a horizontal and a vertical line, we just created a right angle, making this now a right triangle. And that's what this is based off of. The equation of a circle is based off of a right triangle. And if we think about it a little bit more, we now know all I need is this distance and this one. Well, if I know what x is, there's the distance for x. All I have to do is subtract the distance for h, right? Little plus little equals big. Well, I can also subtract for it. So this distance is x minus whatever h is. And I would do the same distance from here to here. If I want to find out how far it is from here to here, well, I would take the bigger number y, and then I would subtract the smaller value of k, because we're subtracting this segment, subtracting the segment here from the bigger segment. And so if we have a full triangle ready to go, the standard equation of a circle basically comes from the Pythagorean theorem. Now, the Pythagorean theorem is, of course, the one that said that a squared plus b squared is equal to c squared, where the two legs of a triangle, if they're given a power of 2 and added together, would match the hypotenuse to the power of 2. So check out this equation. I know it looks a little weird with the way it's set up, but x minus h, of course, I have to give it a power of 2, plus bring in that b value. Well, the b value, I guess, would be the other leg, y minus k in this case, is equal to, now I'm not going to write a c because notice my hypotenuse has the r for radius. So this is why the radius is very important here. And it says the radius to the power of 2. And so there it is, actually. This is the equation of a circle. We don't do anything else with it. Like I said, it is based off of the Pythagorean theorem. So we're going to highlight here first. The equation of a circle is officially, all right, so here it goes. X minus h squared, and yes, the original has to have a minus, plus y minus k squared, and it equals to the radius to the power of 2. So notice we need two things. Number one, we're going to need a radius. So the radius r, that's what we're going to need. And number two, we're going to need a center. And when we say a center, that's where my h and my k come in. Now, understand one thing, though. Here it says x minus h, but notice how I didn't write a negative. This one says y minus k. Notice how I didn't write the negative. The minus signs are part of the formula. So one thing to remember, and this is what we tell students every year, when you're trying to pull this information, the h and k, from the equation itself, you got to think opposite. Look at that. It said minus h. It said minus k here in the problem, but we never wrote the negatives. That is why for these two, we think opposite. Think opposite. Notice we're only talking about the center, but that's why I look at our arrows there. They said minus signs, but they're positive over here. The minus signs are just part of the formula. So let's show you how this works, right? Let me show you how this whole concept of think opposite is going to help us here. So let's move this up a little bit more. We can see the equation. We can see the problems here. So question number one says, write the equation of a circle with this center and with this radius. Well, notice they have given us the two things that we need, which means I'm going to write the formula down the way it officially should be. X minus h squared, y minus k squared is equal to the radius squared. Now remember what we said, we needed three things. Well, I need to know what my h, my k, and my r. Well, there's my h, there's my k, and there's the r. So I do have everything. Now, this is where you have to be careful. Look at how we set it up. X minus squared, y minus, remember the minus sign is part of the formula. It has to be there. And if you notice, I have officially left 3 empty spots. When you use a formula, you're just plugging in. You're not changing anything yet, but notice how the minus signs have to be there. So now, here I go. I already know that my H is 5. Well, I'm just going to put a 5 for now. I know my K is -6. Then I'm going to put a -6 for now. We can fix it later. And my radius is 12. My radius is 12. So here is my official equation of a circle that has this center and this radius. I would leave it as x minus 5 squared. But here, this is where we would change it. A negative times a negative is positive. So we would say y plus 6 squared. And then, of course, 12 squared. That's not 12 times 2. 12 times 12 is 144. And just like that, here is my answer. This is the equation of a circle that that has this as a center and has this radius on it. Now, remember how we were talking about think opposite? Check it out. X minus 5, think opposite. Well, that's a positive 5. Y plus 6, think opposite. The opposite of positive 6, there it is. Look at that, -6. It's when you create your equation that you can do a quick check and make sure that the opposite of what you wrote is being shown as your center. Okay. Now, notice just right below for number 3, we did change the question a little bit, so feel free to take a moment to make that change for number 3. It says if the center is this and the diameter is 18, find the equation of the circle. I think it said something else about area. Feel free to throw that out. We're going to change it to say equation of a circle because that's really what we want to practice for today. So I'm actually going to do number 3 with you here because it's very similar to what we did. Now remember, here's what we need, right? We need a center and I need a radius. Keep that in mind. It always has to be radius. And so when I read this, it says, if the center is 3, -11. All right, so there's my center. 3, -11. All right, I got half of what I need. But then they said this. They said the diameter is 18. They didn't say radius. Up here, they gave me a radius, so I used the 12 immediately. I didn't make any changes to it. But when they give me a diameter, remember what we said earlier. I have to take that 18. It's the only time we ever have to do this, and divide it by 2 because 18 is not my radius, but the 9 is. And so now we're ready for our formula. So here comes the same formula again. X minus squared plus y minus, notice how I'm leaving a little blank space there, because just like last time, there are 3 spots in this formula that have to be filled out. And again, those minus signs have to be there to start it off. And so now here come my numbers. I needed an x value. Well, my x value is 3. See, I don't need to look at my problem anymore. Everything I need is right here. I need a y value. Well, that's -11. The y goes with the y. And then I need a radius. Well, there's my 9. And I'm about to finish here. Just going to do a little cleanup here, a little maintenance. X minus 3 squared. No changes there. But we do see a change here with the y's. Negative and negative is now +11 squared. And of course, 9 times 9 is 81, not an 18. And just like that, there's my answer. This is my equation of a circle that has this diameter of 18, aka radius 9, and it hits that center. Let's check that center though. The opposite of -3, +3. Check. The opposite of +11, -11. Look at that. Check. Think opposite. So now this concept of thinking opposite is actually going to help me out here. Notice this equation. I don't like that they kind of wrote it out like this. So let's rewrite it. X minus 5 squared plus y plus 1 squared is equal to 100. Now here's the thing. They said, hey, tell me what the radius is. Remember, this is my h, this is my k, my x and my y. Think of it that way. But when we're thinking of it as x and y, well, I need an x value. So here's where the x is. But we said think opposite. If this says x minus 5, well, then my x value is +5. If my y value says +1, then my y value is actually -1, right? Because we think opposite. When we're doing the center. Okay. Now, the radius. Now, notice where the radius has always been located. The radius is always towards the back, right? It's the one that's all on its own. It's basically kind of our hypotenuse when we were doing Pythagorean. So we know this has to do with the radius. The issue is that is not the radius. The other mistake that people make is they go, oh, I'm going to divide that by 2. No, this is not a diameter either. The 100 is not a diameter. Keep in mind, to get the 100, let's bring that concept down here. To get the 100, they did this. They said radius squared ended up being 100. That's what equals the 100. So the issue is, well, what was in here? What number do we put in here so that we end up with a 100 as a value? Well, there's an easy fix. You've been doing this since Pythagorean theorem. The only thing that gets rid of a power of 2 is to bring in, of course, square roots. By giving it a square root, we can now see what was in there. The power of 2 and the radical cancel each other out. And then the square root of 100, well, then that's just 10. That's the number that was put in there. And because of that, we now know that my radius is officially a value of 10. So the concept or the idea here is, as soon as they give you an equation of a line, keep in mind, this is the radius, but to a power of 2. So your job will be to take a square root at all times. And finally, question number 4. Does this point lie on the circle with this equation? So they already gave me an equation, and that's fine. I don't have to do any work. They didn't ask to find the center or the radius. They didn't ask us to do that like they did for number 2. They literally said, here, I'm going to give you a point called 5, 3. And all they want to know is, right? So let's pretend here's a circle with all this info in it, with a radius of 5. Remember, my radius would be 5, not 25. They're asking, is this point actually somewhere on here? Is it going to be on the circle somewhere? Well, there's an easy way to find out. See, this is an X. This is a Y. Well, I see an X right here. I see a Y right here. So all we have to do is just plug in. We are going to plug in to find out if this thing works. So here we go. Again, very different approach to what we've been doing. Notice how I'm copying the equation in yellow there. But all I did was I left out 2 values this time. I left out an X value and I left out a Y value because that's where I'm going to plug in. My X is 5. So there's a 5. And my Y is 3. And here's the thing. This is the big question mark. Will it all become 25? Remember, you're not solving. We're just checking. So let's see. 5 minus 2 is 3 squared. 3 plus 1 is 4 squared. And again, the question mark is, will it all equal 25? We don't actually do anything to the 25. 3 squared is 9. 4 squared is 16. Once again, the question is, will it all equal 25? And 9 plus 16 is 25. So then, yes, we have officially answered the question. They are equal to each other. Well, I guess technically we haven't answered the question. The question was, does this point lie on this circle? Well, the fact that the numbers matched up perfectly, here's the answer. Yes, 5, 3 lies on the circle. Now, I should write the equation there, but I know we're low on space. So we'll just leave it like that. And here's my proof. My proof is I plugged in the numbers for X and Y, and the numbers matched. Now, at this point, yes, we still have a little bit more notes that we have to do, but we're going to pause the video for a moment so that you take some time. And here are the problems I want you to work out. You should be able to go to your classwork. So we're going to give you about 10 minutes there. And I need you to work on numbers 1, 3, 5. So basically 1 through 6. You should be able to do with the information you just learned, numbers 1 through 6 on page 17. So take a moment, work on that, and then double check your answers, of course, with the key. So we'll give you a moment to do that. All right. Now that you've had an opportunity to work out how to write an equation of a circle, how to pull information from the equation of a circle, which by the way is going to be the most important part for the second piece here, then we're going to start graphing circles. Now, this is actually for some the easier part. So it says we have a couple steps on how to graph them ourselves. Make sure the equation is in standard form, else change it to standard form. Graph the center, use the radius to graph 4 points on the circle, and then you actually draw the circle. And of course, do as best as you can. It doesn't have to be perfect. What we're going to be looking for, I'm going to be looking for 5 points on your picture. So I'll show you what those are. Now remember, this is why I need you to practice first. We have an equation here, but this is what stands out to me. Here's my x, here's my y, and remember, that's not my radius. We have to do something to it. Remember, for the center, you got to think opposite, only for the center. So if we're going to think opposite for the center, well, I need an x and a y. So if it says x minus 3, then we're going with positive 3. If it says y plus 2, well, then I'm going with negative 2. And just like that, look at this. We have our center. So remember what I said. I need to see 5 points on your pictures. Well, here's point number 1. So 1, 2, 3, down 2. There's my center. But the other thing, of course, is this number right here. The most important number now for us, because we already have a center, is the 9. But remember, that is not my r. My radius squared is equal to 9, which is why we take a square root, and r is equal to 3. That's my radius. My radius here is a 3. I guess I had it here, should just leave it there. My radius is 3. And now remember what we said. I needed to see 5 points from everybody. Here's where the other points come in. If your radius is 3, all you have to do is go 1, 2, 3 spaces over. There's 2 points now. 1, 2, 3 spaces over. 1, 2, 3 spaces over. And 1, 2, 3 spaces over. These are the 5 points that we need. Remember, that's the whole point of a circle. A circle is whatever the radius is, every other point is equidistant from the center. So now let me see. I know I have a tool here to help me out. Let's see if I could find one that works. Yeah, that gets close enough. But just like that, here is my circle. And again, I know it wasn't perfect, but close enough. But that's the idea. Just make sure you count the spaces very carefully. Okay. All right. Let's try it again. So look at example number 2. In example number 2, no, we're going to notice something. This is the y that has the power of 2. But notice, there's no adding or subtracting with the x. No number being added or subtracted. Well, then that just means one thing. If there's no number being added or subtracted to the x, then my x value is 0 because there's nothing being added or subtracted there. But when I look at my y does have a minus 2. We said we're going to think opposite. Well, then it's positive 2. And just like that, we have our center. Now remember, 0 means we're not going to the sides. We're just going straight up 2. There's my center. And of course, we now have to think about our radius. So here's where my radius kicks in. And yes, let me just throw this out. Radius squared is equal to 36. Remember, this is how we set it up because you need to be reminded that, yes, we take a square root and my radius is just that 6. So all I have to do now is count 6 spaces. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Remember, we're counting 6 in every direction from the center. This is where we create. Well, let's count 1, 2, 3, 4, 5, 6. This is how we create our circle. I have to have 5 points. Of course, I'm not going to touch the center. The center is just the center. But now I can actually draw this circle. Let's see how close I can get this time with this tool, if possible at all. Well, maybe not. Nope. I think I got one there. That might work. There you go. So here we have our circle. Again, you may not have the tool. That's fine. Do the best you can. Just make sure you show all 5 points. That shows you have an understanding of the material. So now we're going to quickly finish these here. Again, it's all about thinking opposites. I see a number being added to the x, then I'm going to think opposite. And so my x value is -2. And then when I look at my y, once again, we get a situation where nothing is being added or subtracted to it. And so because of that, we're going with the 0. All right, so we have our center, -2, 0, back 2, and then I stay there. So there's my center, -2, 0. And now we just need a radius. Well, we've talked about radius. We said it has to do with the 16. It's not the 16. So I'm going to say radius squared is equal to 16. We take a square root of both sides. And here comes my radius of 4. And just like last time, all I'm going to do is count 4 spaces in each direction. 1, 2, 3, 4. 1, 2, 3, 4. 4 spaces. 4 spaces, and just like that, here come the other points for my circle here. Because once you get the hang of it, it becomes one of the easiest things to do. And let me see if I can find one that works. I think this one gets close enough. So here is my official circle. And again, what matters is those 5 points. You see, I missed that there by a little, but close enough. Okay, so I hope you're getting an understanding. It's a very simple concept. Again, this one has addition, this one has subtraction, but they both have numbers, but you have to think opposite. If it's x plus 4, then we're going with -4. If it's y minus 3, then we're going with +3. And then I draw it. Back 4, -4, up 3. And if you notice, this radius looks very similar to us, right? Or the 16. What's going to help us find the radius, because remember, that is not the radius yet. We need it to help us find it. And so we take a square root, and my r is simply just a 4. So we go 1, 2, 3, 4 spaces, 4 spaces in every direction. And of course, we connect our dots to finish our actual graph of a circle here. And let's see if I guessed it right here. Yep, there you go. So once again, when you're graphing circles, you just need 2 pieces of info. When you wrote the equation of a circle, you needed a center and a radius. When you graph a circle, you need a center and a radius. Notice how we always need those 2 pieces of information. All right, so with that said, you now have everything you need to complete your classwork on the following page. Remember, you should have already done numbers 1 through 6, but now, of course, you can actually do numbers 7 and 8 because you know how to graph now. So let's start becoming better at it and become some experts. All right. With that said, don't forget, you also have a homework assignment on big ideas. Have a wonderful day, everybody. And then I'll see you next week.